module prepared by Professor Amit Tata, School of Business, George Mason University. In this module, we'll look at a small variation of the moving average method of forecasting. So let's start off with some time series data. In column B, you can see that we have a history of prices of some item from 1990 to 2011. And we're going to look at this method of forecasting. So for a visual image of what this time series looks like, this is the chart. The blue line shows the pattern of prices over that period of time. Notice that the pattern shows a clear upward trend from the start till about period 17 or 18 thereabouts, and after which it drops for a while up to period 21 and then rises again. So there's a very clear increasing pattern till at least about period 17. So now, as a baseline, let's do our usual moving average method. You remember that in the moving average method, the forecast for the next period is an average of the actual values for the current period and a few periods prior to that. So let's say we'll use a window of size 3. So the first period for which we can make a forecast is period 4. So here we go. So this is the fourth period, and using the regular moving average method, the forecast for period 4, that is 1993, would be the average of the previous 3 periods. So that's 123.7, and this is the method we will use to forecast all the subsequent periods. Okay, so just to draw the graph, I'm going to copy these numbers over to this fresh column over here, and you can see in the chart below, the brown line is the forecasted values using a 3-period window. And one noticeable characteristic of the forecast is that it is consistently below the actual values till about period 17. And it's not surprising because the forecast is an average of the prior 3 periods, and we give equal weightage to the 3 periods. Okay, hence we are never quite able to catch up with the increasing pattern in the data. All right, so to take care of that, a little variant that one can do on the moving average is to weight the different periods in the window a little differently. All right, so here we go. Again, I will have a 3-period window, but instead of giving equal weights to the prior 3 periods, I will weight the more recent observation more heavily. So my forecast for the fourth period is equal to 0.8 times the most recent observation, which is the observation in period 3, plus zero point 0.1 times the observation 2 periods back, plus zero point 0.1 times the observation 3 periods back. Notice that the sum of the weights is 1. 0.8 plus 0.1 plus 0.1 is 1. But I've given more weight to the most recent observation. Okay, so this gives me my forecast for the fourth period, and I will copy this formula down for the remaining ones to get my forecast using this weighted moving average. So to see visually what we have done, the results of our operation, let me copy this number over here to this column. You can see at the heading for column L is F3 weighted. Okay, so let's look at the chart over here. You can see in the chart the green line that you see is the forecast obtained through weighting, and you can see it is closer to the blue line. All right, so we have shifted the brown line up. In other words, we're doing a better job of following what the actual pattern is. All right, and we have been able to do that simply by giving more weight to the most recent observation, hence the name weighted moving average. And a weighted moving average is good, is useful when the data has some trend in it, whether it's increasing or decreasing. Then the weighted moving average would make sense. Okay, but you have to choose the weights judiciously. If you give too much weight to the most recent observation, then of course you're becoming more hair trigger. Okay, at one extreme, if you give all the weight to the most recent observation, you go back to the naive method of forecasting where the current period's value is the forecast for the next period. Okay, so you can overdo the weighting. So the weights have to be chosen judiciously. Mathematically, the only constraint that you have to follow is that the sum of the weights have to be equal to 1. So this is the weighted moving average, which is basically the same as the moving average with a slight twist in that the different periods of the window are weighted differently. Now, there's no reason why the weights have to be in increasing or decreasing order for the different periods in the window. As long as the weights add to 1, mathematically you're fine. But typically, you give more weight to the more recent observations in order to keep up with any trends that might be occurring in the data. So this is a slight variation on the moving average method of forecasting called the weighted moving average, for pretty obvious reasons.